Integers, okay, integers and then float.
Correct. Yeah.
Float means basically decimal only. Float because it has the floating point.
Yeah.
Okay. So that's why. So those are numeric and non-numeric. Right.
Yeah.
Right. Now, see, before understanding like the questions which are there in our question bank, so that is the data structure. So we will dive into data structure.
Yeah.
What is a data structure?
Yes.
Right.
Yes.
So this code is okay. So I will, if in fact, if you want, I will just maybe send the code to you.
Yes. Yes. Please.
In chat. Yeah.
Yeah. So,
Just a simple declaration.
You've written gender is equal
That's
to 8. You've written gender is equal to 8, but it doesn't mean anything, no? It is not a. It doesn't make any sense. It doesn't make any sense.
Gender is equal to 8. Yeah, it doesn't make any sense.
Okay.
Syntactically, though, I can do it.
Yeah, I understand. Yeah. You're just trying to show me that if you write a number also, it is still character.
Within single quote. Within single
quote, yeah.
Yeah.
Because gender is a character.
So take this code down somewhere.
Yeah. I will if you put it on WhatsApp, no, then I will print it out.
Okay. Okay, just hold on one.
Just copy paste it on if you copy paste it on. Or take a picture and screenshot and send it to WhatsApp also.
Yeah, sure. So I'll send that.
Thanks.
Meanwhile, so data structure, as we discussed, is a complex arrangement of data types, right?
Yes.
Data structure means what we are now going to do is we're going to make some arrangements. Okay, with the data types. Like I'll show you what we can do. I will show you.
Yes.
1 second. Okay, so I'll just now just share back the screen. Okay, so I will remove these lines of code now. So okay, how do we create an integer? Once again, so how do we create an integer?
How do we create an integer?
Yeah.
So after int main, you have to write which integer, a, b, a value is how much, b value is how much?
Any some value. Yeah. So we write int space a. And we just give a equal to 5, right?
Yeah.
We do this.
Yeah.
Okay.
Yeah.
So the value a equal to 5.
Yeah.
You can give equal to here a equal to 5. You can give it here itself also.
Yeah. Okay.
Okay.
Yeah.
Mind you, so the value while you are declaring a itself also you could give.
Yeah. Okay. Declaration.
While declaration itself you can also assign the value.
Okay.
That can be done. Okay. But that's just a small thing. So that can be done there. Now here's the thing. I want to create some like I want to create a few number of integers. Let's say in a class, right? In a classroom, you have some number of students. Let's say 40 students.
Yeah.
And I want to store their marks as such. All of those students' marks, the exam marks.
Yes.
How much ever they scored in the computer science exam, I want to store that.
Yes.
So my question is this.
Yes.
How many variables would you require if you keep on declaring?
Yeah.
So how many variables would you require?
For all the 40 students. 40.
Right. So you would require, technically speaking, you would require 40 variables.
Yes.
Here's what array does.
Yeah.
Okay.
Yeah.
Here's what an array does.
Yeah.
So it helps us to create
yeah.
a set of integers for us. So let's say if I say int space a square bracket 40. Okay. And then I, of course, the semicolon.
Square bracket 40.
So now I am declaring a as an array.
Yes.
Okay, here.
Yes.
If I say this statement, right?
Yeah.
Okay. If I say int a, then followed by a, I'm putting the square bracket and then some number.
Yeah.
Then I'm declaring an array. Okay.
Yeah.
What do you mean by an array? So you may say array means basically in English, say if let's say you have a shelf where you put books one after the other, right?
Correct. In AutoCAD it is there, no? Array is there in AutoCAD, that function, array.
Yeah. So it is basically like that. Okay.
It keeps on repeating.
So it's like if you have a figure, you can multiply it
you
like
can multiply
2 or...
Yeah. That function is there in AutoCAD.
Yeah. Correct. You are right. So that is, So basically the point of an array is, so it's like multiple storage. Okay. So this data structure, what is this? The use of this data structure is, it allows for multiple storage.
Yeah.
Okay.
Where is it?
But
In which part of the computer this data is stored? In that.
Which part of the computer?
Yeah. Is it in C drive, D drive, RAM?
No. Whatever program we run. So there is a thing called.
No, this array. No, this array we are asking for 40 variables. No, we are asking for that. So which part of the computer is this array? Are we getting the space from? In which part of the computer?
So for one integer, it takes 4 bytes of data. One integer takes 4 bytes of data.
Correct.
Okay. Now for 40 integers, how much data would be required? You can now compute.
160, no? 160 bytes of data.
160. Yes. Correct. Correct. Yeah. And 160 bytes we require continuously. 160 bytes of data in the memory somewhere we require continuously.
Correct.
Okay.
Yes.
That's one thing. But which memory? Continuously I require some 160 bytes in the memory, but which memory?
Yeah.
So not the static memory. Not the static memory, right?
Yeah.
So C which you are running, the program which you are running is basically an application, right?
Right.
It's an application.
Yeah.
So it is going to it's going to need the RAM.
Correct.
Simply speaking, it's the variables which you store will be stored in the RAM. Okay.
Yeah. But then it will disappear because it is random access memory, so it will just be used for a short time and then it will disappear also.
Once I close this C program, however, I don't need it anymore.
Right.
Yes?
Yeah.
I don't need it anymore, so it will disappear.
But I want to ask you something. Now we are using this online compiler, no? That's why we are doing it like this. Suppose I download a compiler in my computer. I download a compiler.
Then as well. I'll tell you. Then as well, because this online compiler, as you said, runs online.
Correct.
However, you see, I am using Chrome.
Yes.
Correct?
Yes.
To open this online compiler.
Yes.
Yes.
Yeah.
Of course, the online compiler is basically a part of a server, right?
Yes.
Which is providing you that RAM.
Correct. It is a .com server, no? .com.
Here's the thing. So that server is providing you some RAM.
No, sorry. Is it .com? This program is?
Yes.
Okay.
Yes.
Okay.
Program is .com.
Okay. Okay.
So, that server, from that server you are getting the RAM. Okay.
Right.
Anyway, even if you check your task manager, Google Chrome is now going to take up some space in the RAM, right?
Yeah.
Never the ROM. Okay, never the static memory.
ROM
Okay,
is ROM. What is the full form?
Read only memory.
Okay.
Okay.
Yeah.
Okay.
Yeah.
So ROM.
Yeah.
See, it's not going to take up space from the static memory. No.
Yeah.
Okay.
Yeah.
Even if you download, let's say you said, right, even if you download a particular application,
Yes.
which you run in your laptop offline.
Yes.
Yes.
Yeah.
That application offline is going to send the variable data to the RAM.
To the RAM of my computer.
Yes.
Okay.
Yes.
Okay.
So because once you close this, okay,
Yeah.
so there is an into mark here.
Yes.
Okay, once you close this,
Yeah.
the variable does not need to exist in the memory. So that's all clogged up space.
Right. But if I download the compiler in my computer, then all these programs which I have made will stay in the compiler. It will not go away. It will not go away. Yeah.
I will tell you.
Yes.
If I copy this code.
Yes.
Okay.
Yeah.
If I copy this code and if I open a file.
Yeah.
Through the application, if I open one file, save it as let's say first edition.c or first edition.txt.
Yes.
Like in a text file.
Yes.
That is static memory, right?
Yes.
Means you are storing that edit. See, this lines of code you are storing as a text file in your static memory in your computer.
Static memory is in C drive, D drive, and all that.
Those things. Okay, yes. Okay. You can save a program. Since it's editor, right? See, this is an edited program, isn't it?
Yes.
I wrote some bunch of lines.
Yes.
Text lines.
Yes.
These are text. Yes. You can eventually say. Yes. So these you can of course save it in static memory. Okay. But the variable, right? The variable when you run it, that variable will be invoked. Okay. That too not in the static memory, but rather in the RAM memory.
Okay. I understood. Yeah, I understood.
Okay.
So we are taking the array. We may
yes.
The array may be in RAM or the array may be in static memory, depending on what we are storing.
No. So why would
array is always in random access in RAM.
Yes.
Okay.
Yes,
no, I thought if we are storing that, after you copy it in text and all, and then we are copying it in static memory. In static memory, when we store, we don't need array. We don't need array.
No. So static memory, when it is stored, you are storing the text, right?
Yeah.
In a txt file, .txt file.
Yeah. So then we don't need array.
Some letters. There we don't need.
So
why do you need to store the value?
Okay. Yeah. So how is it stored in static memory? In what form? That is not data structure.
So that is through what is called as file input output operations. Okay.
Yeah.
File input output operations.
So that is not called. That is not in that within the scope of the syllabus of data structures. That is not.
It is a separate. File handling is a separate business. Okay.
Wow. So this is mind blowing, because I thought, for me, when I think of memory, I'm thinking of this external hard disk, hard drive. This is what I'm thinking of. So all these data structures are only for random, only for RAM.
But you could store it, however. See. What I could do. Yeah. Let's say is, I give some values to my array, right? A0 is this, A1 is this, A2 is this, and so on. I give some values, right?
Yeah.
After I give some values, I could transfer that data using a file printf option. Fprintf it is called.
Yes.
Means fprintf, if I do, I will have to give the file name and then whatever I am writing it inside whatever I am trying to write inside the file.
Save file. If I do save file.
So if I do that, so then inside a file, this data will be written.
Yes.
Okay.
Yes.
So that is file input.
But then for that array and all, what we are studying is not related to that. What we are studying in DS is not related to that. That is separate. That's file input output thing. That's another thing altogether.
DS data structures are for data manipulation, basically. How you manipulate your data.
And
like here we made
not static data, but in RAM.
Correct.
Yeah.
Manipulation.
But
That's
in
it. It's
RAM,
like you are
RAM,
making it
yes.
as an array.
But in RAM, it is always stored as 0 and 1, it seems, no? Finally, it is stored as 0 and 1.
Right. So when I said an integer,
Yeah.
how much size does an integer need?
4 bytes, you said, no?
Yes, 4 bytes.
Yeah.
So what is 1 byte equal to?
1 byte.
What is 1 byte equal to?
4 bytes, 1 integer. So 1 byte will be 1/4 of an integer.
No.
You mean how many bytes is 1 MB or 1 MB, you mean? 1 KB, 1 KB. 1000 bytes is 1 KB.
That is 1 KB is 1000 bytes.
Correct.
Right.
Yeah.
Right. So bytes, you agree, is the smallest unit, correct?
Right. It is just one electrical signal, no? On, off.
No.
Oh, sorry.
Not really.
Okay.
Byte, when it comes to the hierarchy of storing files,
yes.
byte is the smallest, right?
Okay.
But 1 byte is again equal to 8 bits.
Oh.
8 bits.
That is what you see in those pixels, no? Pixels.
Correct. So you said electrical signals, right? So you said electrical signals,
yes.
0 or 1.
Yes.
Specifically, it can only be an off or an on.
Right.
Yes?
Right.
Okay, so logic 1 is actually called as on.
Yeah.
Okay. Yeah. Logic 0 means actually it is off. Okay, so the switch is off, basically, we say. Yeah. So every byte.
Yes.
So we said one byte is how many bits?
8 bits.
8 bits.
Yeah.
So every bit is now either going to be a 0 or a 1. 0 or a 1.
Oh.
0 or a 1.
Okay. Yeah.
0 or a 1. Like that. So you will have, like that, you will have 1, 2, 3, 4, 5, 6, 7, 8. These many bits in 1 byte.
So in the in the array, it is stored as 0 or 1, or is it stored as characters and integers?
I will tell you. There is complexity in this.
Okay. Got it. Yeah.
So an integer is how many bits? Basically?
An integer is 4. An integer, I'll tell you. So one byte is 8 bits. So one integer is 4 bytes. So 4 into 8, 32 bits.
Right. 32 bits.
Yeah.
Okay.
Yeah.
Now you may be wondering how an integer.
Yeah.
Like 630, not 637, let's say 63. Suppose if I say 63.
Yeah.
How may I represent it as bits, right?
Correct.
You may be wondering. Okay.
Yeah.
Bits, wherein you can't even write 6 and 3 here. In bits, right?
Yeah.
You can't even write 6 and 2. You can only write 0 or 1, as I said. Only possible numbers
right.
0 and 1 in a bit.
Yeah.
But how do you represent 63 as 0
I
and
know.
1?
There is some code given for each A, B, C, 1, 2, 3, 4. There is some code given. There is one list is given.
Correct.
Yeah. Correct. Somebody told me that.
So how do you represent any integer as binary notation, it is called. So zeros and ones, right? When we say zeros and ones, so that's a binary notation.
Okay.
I will tell you. Simply how you do that, I will tell you.
Yeah.
So this last place is actually 2 to the power 0. This is 2 to the power 1. This is 2 to the power 2. This is 2 to the power 3. Okay.
Yeah.
So this is 2 to the power 4. This is 2 to the power 5. This is 2 to the power 6.
This is already written by the first person who did the binary notation, no? This is already there. Like, we can't probe deeper into it. The person who made this code, that basic code, he already did this, and we are all following that.
Place value, face value system, you know, right? See, place value, face value. It's a little bit about place value and face value.
I don't know place value, face value.
I'll tell you what that is.
Yes.
Suppose if I take the number 637.
Yeah.
What is that? I can basically build it as 6, 3 and 7, right? In 3 blocks.
Yeah.
7 into, can I say 10 to the power 0?
7 is 10
This is units place, right? So this 7, the place of 7, which is to the extreme rightmost.
That is 2 raised to 0, na?
10 in decimal. First I'm talking about in decimal system.
So 2 raised to 0 is binary notation.
That is binary system. This is binary system.
Okay. So now there is another decimal system.
Huh. In decimal system, this is units place, right?
Yeah.
So decimal system means 10. The base is 10.
Yes.
So that's why 10 to the power 0. Okay.
Yeah.
This place is 10th place, right?
Yeah.
It means 10 to the power 1.
Yeah.
Okay.
Yeah.
This place is 10 to the power 2.
Yeah.
Okay.
Yeah.
Simply speaking, what am I writing here? Can you not write 637 as 600 plus 30 plus 7?
Yes.
Can
yes.
you not write this?
Yes. Yes, we can.
We can, right?
Yeah.
We could write it in the expanded form.
Correct.
What is this 600? I can write the 600 as 6 into 10 to the power 2.
Yes.
So you see?
Yes. Yes.
So is there some connection here? 6 into 10 to the power 2.
Yes, there is a connection. Yeah.
330 means that is 3 into 10 to the power 1.
Yes.
3 into 10 to the power 1.
Yes.
Okay. Plus 7 into 10 to the power 0. Actually, 10 to the power 0 is 1, right?
1. Yeah.
So if you see, 10 to the power 0 is actually 1.
Like we say ones, tens, hundreds, thousand, 10,000, no? We write. Yeah.
That is in school.
Yeah, that is in school. Yeah.
But now you have to graduate to the college level.
Yes.
So that is 7 into 10 to the power 0.
Yeah.
Okay.
Yeah.
You got it.
Yeah.
So any system as such, any system,
Yes.
you will take the powers of the base.
Yes.
Like how we took 10 to the power 0, 10 to the power 1, 10 to the power 2. If it is an even bigger number, let's say in lakhs or crores.
Yes.
So you will have that many 10 ka, that power will be raised to that
just
much.
As in binary system.
Right. Now, why can't we just have the numbers in the binary? Why can't we just store this 637 as 637 itself in a computer?
We cannot.
Is because we cannot. Is because the person who made the computer as such made it using a binary notation, right?
Correct.
So all throughout, anything you want to do with a transistor, so that the problem is, so there is a device called as transistor, right?
Yes, in the radio.
So
but not the same,
like
not the
radio,
same in electronics.
In electronics,
it's semiconductor, no? They call it semiconductor.
Exactly. In semiconductor, so basically computer is basically made up of these chips, right? It's all the chips, which are basically semiconductors which release this ones or zero signal. That's it.
Oh,
that's it.
So that's like a transistor only, na? In a radio also they are emitting signals, no?
Correct. So what a semiconductor is efficient in doing, right? If required, it can give a signal of 0. If required, it can give a signal of 1. So we can manipulate the signals with the power being still on. You cannot do that with an electrical system, right? See, think about it. I have an electrical system.
What's the difference between electrical and transistor is electronic? Transistor is electronic?
Exactly.
So electrical is when we are putting it onto the main switch of that 240 volts.
I will tell you. Electrical means
AC/DC
right?
current, no?
Power you are supplying. Power you are supplying, right?
Yeah.
But you cannot make it as a signal.
Correct.
So
Yeah.
Okay, got the point. So, but you cannot make it as a signal.
Like FM radio emitting signals at a particular wavelength or frequency or something, no? FM radio, and then you catch it with a walkie-talkie. Like you can have your own radio station.
Simply speaking, current while it is on, let's say, you can never break it in an electrical system. That is the electrical system. We could never break it.
Right.
Electronical system. Okay, so that's what is the thing, right? So when there was one professor, especially I remember, who specifically just talked about this thing.
Yes.
There is an electronics department. There is an electrical department. What's the difference between electronic and electrical?
Nobody explains all this.
Nobody. In fact, none of the students, actually, you can imagine, none of the students could say what is. Some people were saying Ohm's law, some people were saying the theory, right? Basically, what we learned, V equal to I. So they were basically saying that. They were saying all that. Simple, I'll tell you.
Yes.
Electrical systems, you can never break the power.
Yes.
Okay.
Yes.
Which is the reason why. Something catches fire, it's like a lot of power loss.
Correct.
You have a TV in home, right?
Yes. It was there for 25 years, but then it got spoiled. I brought it from the UAE. It's spoiled now. I don't have a TV.
No, I mean, so let's say let's say we are back in the time where you did have the TV,
Yeah,
right?
yeah.
So
A
my
long time,
point
yeah.
is,
Always it was
my
on.
point is,
Always it was on. Yeah,
but although it was on,
yeah.
did it consume a lot of power?
No, very little. Because it is DC
Not
current or something, no?
not really, not
No.
really.
Okay,
So
okay.
it is this current. It is the signal current.
Oh,
So
okay.
the thing with semiconductors, right?
Yes,
The thing
yes.
with semiconductor is
Yeah.
we can reduce the power consumption. We can
Right.
actually consume only that much power which we want,
Okay.
right?
Okay.
You got the point?
I got the point.
In a
I got
much
the point.
larger sense.
Yeah.
In a much see, semiconductor in
Yes.
electronics we are saying semiconductor. In
Yeah.
electrical, what are we saying? That as conductor, right?
What conductor it has?
What's the difference?
What's the conductor in
What's
electric?
wait. What's the difference between a conductor and a semiconductor? What is the
I don't
difference
know.
in
I don't
word?
know. I'm just saying semiconductor because everybody is saying semiconductor.
No. That's okay. You may not know what a conductor also.
Yeah.
Wording wise, I'm just saying the
Yeah.
semi is different, right?
Yes.
Are you getting the point?
I got the point. Yeah.
So it is conductor is something which is always going to allow the passage of current.
Conduct is a copper wire.
Copper wire.
Yes.
Simply speaking, a copper wire.
Yes.
A copper wire does not know to regulate the current.
Correct.
Let me tell you.
Correct.
A copper wire will fail to regulate the current.
It's not
Okay.
It's not a smart conductor.
Exactly. Rather, it's not a semiconductor.
Right.
Yes?
Right.
It's not a semiconductor.
Yeah.
A semiconductor is something at certain voltage,
Yeah.
the conductor would just shut down. It will not pass. It will not allow the current to flow through.
So,
Are you getting the point?
yeah, but it is much less than DC current also. DC current also stops at a particular voltage, right? That adapter for the AC.
Actually, DC or AC, it's the point about power consumption. The point is about power
Semiconductor
consumption.
is much less than that DC current 12 volts also, no?
Way less.
Way less
than
yeah.
what electrical devices
Yeah.
actually consume,
Correct.
right?
Yeah.
So that's why you will see fan, inside the fan you have a small circuit, okay?
Yes.
Inside a light you have LED lights, okay?
Right,
Which
right.
is actually a diode, which is just the same principle as the semiconductor,
Right.
okay?
Right.
Electronic,
Yes.
making it an electronic device.
Acha,
TVs.
Yeah.
TVs are LED. See, you have heard about LED TV, LED screen TV,
Yes,
right?
yes. But I didn't have LED, yeah. I had that old type.
Okay.
Yeah.
So, but the point is,
cathode ray tube.
oh, okay.
Because mine was
cathode
very
ray. Yeah,
old, na. I brought it in 97.
I remember I used to watch in my grandpa's house. There was one, Shivaki. Yeah, especially I know the name also of the
Yeah.
TV.
Yeah.
It's Shivaki. Yeah. Very standard company. They had it almost I think they had it quite long.
And our first TV we had in 82 when the World Cup was going on. So that also was cathode ray tube only.
Oh, okay.
That Onida and all, you remember that Onida and all? Yeah.
Those are the quite older models.
Yes, yes.
Yeah. Okay. So my point is, so we'll jump back here.
Yeah.
Okay.
Yeah.
So the way computer is designed is, it's only designed to note these binary notations.
Yeah.
Simply speaking, everything, every chip, okay, that is there inside a computer, right? Okay, knows only a 0 or a 1, right?
Yes.
Okay, you could use an LED screen to display that 0 or a 1. So have you seen in railways, they will show the 0 like this, or this actually an 8.
But can I see the 0 and 1 on my screen?
If you have the correct interfaces, right? If you have the correct interfaces, you can actually see what does a projector do. What do you think a projector does? If I connect my computer with a HDMI cable, it's called.
Yeah.
Okay.
Yeah,
with a
yeah.
HDMI cable.
Yeah.
So I can connect it to a projector, right?
Correct.
Which will project whatever I have this on my screen to the board or to the other end, right? Where you are trying to present something.
Yes.
Right?
Yes.
You get the point. So it's like if you have an interface, you can project anything. My point being, so the computer was, as I said, a bunch of semiconductors, chips basically, which could transmit a 0 or a 1, and of course you could display selectively if I wanted. In an LED I can show
in
a
the
0.
older computer, in the older computer which I had in 2002, at that time initially when you switch on the computer, this basic this binary notation was used to come on first, like before the computer would totally turn on. The first it would be a blue screen and some.
You won't believe it still works sometimes. When I see my computer, when it starts up, when it boots up, right, it still shows the 000s, and then it kind of then shows my Windows system.
Correct.
Then I log in.
Yes.
So that's the thing is, so the only representation that you can have, that you can exploit in a computer, is the binary representation. Yes. Okay, that's understood. Now I will just one example number I will just show you so that you understand the binary. Right? So this is 2 to the power 0. According to the binary system, this place is 2 to the power 0. 2 to the power 1. 2 to the power 2. 2 to the power 3. So whatever number you have here, you have to multiply that with 2 to the power 3. Right? That's the meaning. Okay? And then 2 to the power 4. And then 2 to the power 5. And then 2 to the power 6. And then let's say 2 to the power 7 also. Fine. Okay. What is the number in discussion? 63. Right? 63. Okay. See, if you had a 1 here, 1 over here in 2 to the power 6. So 2 to the power 6 is actually 64. I'll tell you the value. Had it been that you had a 1 over here, so 1 into 2 to the power 6, wouldn't that itself just sufficed to make 64?
No.
It would. See, all the rest of the digits could just be zeros. 0 into this, 0 into this, 0 into... I don't need any of this. Acha, remember,